Let's look at another question. Let's see. So this question is by KG Moila, our biggest fan, I must say. KG, you are on a roll with these questions. I'm going to try to see what is written here. So we have pure hydrogen iodide, which is sealed at 2 cubic decimeter container, and we are given the temperature, which is 721 Kelvin, decomposes according to the following balanced equation. So look at this one, guys. Look at this question here. It's 2Hi, H2, If I go back to the question that we did here, it is exactly the same thing, but now they've given us the reverse of this one. This and this one is exactly the same thing. They've just given us the forward reaction and the reverse reaction on the other one. So, which actually shows you the more past papers you practice, you will actually start seeing a common trend, which I actually like. So now we have the graph below shows how the reaction rate changes with time for the reverse reaction. Remember, when we talk about the reaction rate, we talk about how fast or how slow a reaction can occur. I just want to add on to that when we're talking about reaction rate. There are certain factors that can either make a reaction go faster or go slower. I remember the last time we spoke about having a catalyst, an increase in temperature, which increases the kinetic energy, a change in volume, surface area, whether we use powder, whether we use solids, granules, and so forth. So that's what we're talking about when we're talking about the rate of a reaction. But now I can see that they're bringing in rate of reaction within the equilibrium. So here we have a graph. Oh, KG, was this part of your homework? So I can see, let me just go down here. So here we have a graph. I can see something is decreasing on one side, something is increasing on the other side. We have something moving down. Now we know that spikes usually mean concentration if they move up, but we can see, in this case, it's vice versa. Then gradually something also being used. We have the reaction rate, and then we have that in terms of time. So let's see 6.1. Write down the meaning of the term reversible reaction. Now remember, most of the time they give us a reaction with those funny looking arrows, but in this case they want us to define it. So that is 6.1. So a reversible reaction. A reaction is reversible. Action is reversible when the products can be converted back, that's a ugly back to reactants. And that is as easy as that. Let's look at 6.2. Let's look at the next question. So the next question says, how does the concentration of the reactant change between the 12th and 15 minutes? Let's see. We have the 12th. If you're in exam and you're feeling a bit confused, use highlighters. So how does the concentration change between the 12th and 15 minutes? Write down increases, decreases, or remain the same, and this is only for 1 mark. Now we can see that it is a straight line between the solid line and the dotted line. Straight line means equilibrium. Do we have any concentration change? No, we don't. So that means there is no change at all. There is no change. And just to also give you guys a little bit of an advice, it's very crucial that you actually practice these types of graphs, because what you'll continue seeing is that, oh, if there's an increase in temperature, it has this shape or it has this dip. Oh, when there's a big spike on the one, it means that concentration was added. If both are going up or down, it means that temperature is affected, because temperature can affect the reverse and the forward reaction. So the different spikes on the different graphs can actually give you an idea of what factor was then actually changed within the equilibrium. In this case, we have a straight line, and we know when we have a straight line, we have equilibrium. It means that nothing was then changed, no change at all. Let's look at another question. So it says now 6.3, the rate of both the forward and reverse reaction suddenly change at 15 minutes. So before we answer, I want us to actually analyze. So I can see that the solid line comes up to 15 minutes here, and it drops down and then gradually starts increasing, where the dotted line comes up to 15 minutes, and then it gradually starts decreasing. So now let's see what the question that they're going to ask us says. It says, give a reason for the sudden change in the reaction rate. Remember, reaction rate does tell us that how fast or slow something takes place. So we have a dip here, which means that then temperature was then decreased, because I can see that my reactants were going well, then it dropped, while my dotted line was actually forming, and then it also then dropped. So it means that there was a temperature decrease, and that was for only 1 mark. So this was 6.3.1. I just want to put in brackets. So we can say the temperature was decreased. Decreases. Let's see, we probably have to explain this one because they love explaining it. And it says, fully explain how you arrived to this answer here. Then again, if you got the previous answer incorrect, if you can state Le Chatelier's concepts correctly, you are then able to fix your incorrect mark or answer on the previous one. Let's see what Le Chatelier, or how I would say, how Le Chatelier will then explain this one. So this is 6.3.2. So now remember what Le Chatelier says. He says, a decrease in temperature, decreases the rate. We know that the particles will lose the kinetic energy. Moving back to the kinetic molecular theory, both the forward and reverse. The forward and reverse reaction. And a decrease in temperature favors the exothermic. A decrease in temperature. A decrease in temperature favors the exothermic. Favors the exothermic. Favors the exothermic reaction. So it means the rate of the forward is endothermic, and then it just becomes slower. So that's then how you'd have to remember or answer it. Remember, 3 marks means 3 points. Make sure that you use Le Chatelier's principles to do it. Thank you so much for joining me yet again on this episode. Thank you so much for all your questions. Glad I could help, and I will see you next week, Tuesday.